Hi everyone. Today we're going to walk through the steps needed to verify the stability of the MTP for sent SPC. Sent SPC, or serialized sent, utilizes a master trigger pulse, or MTP, to identify which sensor a message originated from. As with any pulse width modulated system, it is critical to verify that the MTPs remain within tolerance, and we'll be showing the most efficient way of doing that in this video. In this example, we are looking at a sent SPC system with 4 slave sensors on the same wire, each with a different MTP length. Their MTP lengths have been entered into the corresponding 4 ID fields on the Sent SPC Setup tab so that the frame source sensor is identified. Decoding the length of the MTP indicates whether the MTPs are matching the expected lengths on an instance-by-instance basis. Using the column-to-value measurement parameter, the decoded MTP length can be passed through and displayed in one of the oscilloscope measurement parameter slots. And by turning on statistics, the mean, minimum, maximum, and standard deviation of that value can be displayed. Histogons can also be enabled to quickly histogram the distribution of the measured values right on the measure table. Note that there are 4 distinct peaks in the histogon, which is expected given the 4 slave sensors in the system. However, the statistics readout shows a mean MTP of 50 microseconds, which does not correspond to any of the sensors in the system. A mechanism is needed to isolate the traffic from each slave sensor. This can be done by filtering the result table ID column to contain only a single value from 0 to 3, which limits the results to only the traffic from that one particular sensor. The decoder is now only decoding frames with ID 0, where the MTP pulse value is around the expected 16 microseconds. The measured values displayed in the statistics readout from P1 will now give us a sense of the variability of the MTP from ID 0 in this acquisition. The mean value is right around 16 microseconds as expected, with a standard deviation of 38 nanoseconds. While a parameter with statistics can provide a sense of variability and dispersion of the MTP, it does not provide any insight into what the cause of that variability might be. Check out our application note, which describes how this can be accomplished using a track math function and how to automate MTP stability testing using pass-fail. Additionally, to learn more about Sent and Sent SPC, click the link to check out the other videos in our Sent series.